Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about 8051 internal block diagrams. Look at this block diagram. It consists of this is ALU, arithmetic and logical unit, and this is program status word, and we have this temporary register. This is temporary register 2, this is temporary register 1, and this is accumulator. So ALU is for arithmetic and logical units. So all the arithmetic and logical operations will be performed in this unit only. So whenever you are performing some arithmetic and logical operations, we need to have two datas. So look at this. So these two data come from these two temporary registers. So one is comes from this accumulator, or another possible directly also possible. This is the actual data lines. From this we can copy to this temporary register 2, also temporary register 1 also. So depending upon that the two data we are going to perform arithmetic or logical operation, that will be loaded in this temporary 1 and temporary 2 register. After computation we get the results. So this also normally will be in the same size. 8-bit means we have a same 8-bit. So that will be connected to the data bus. And this is a program status where the after computation results we may have some flags. For example, if you are adding two numbers, we may get auxiliary carry or a zero flags or a sign flags. So these will be updated in this flag register. This is called program status word. So after each computation, this program status word will be updated. That is also connected to the data bus. Look at this. This is the registers. This is accumulator and this is B register. This is the RAM address generator and this is RAM. So internal RAM, any locations can be accessed by giving that particular address. So this is the RAM address generator. This is actual RAM. So 4 kilobyte means 4 kilobyte things. So here it's RAM. Each location will be accessed by this register. We have 4 ports. Look at this. This is a port 0 and this is port 2 and this is port 1 and this is port 3. Look at this. Each port have an 8 lines. Look at this. This is a port 1. So we have a port 1 0 to port 1 7. We have an 8 lines. Similarly, if this is port 3, we have port 3 0 to port 3 7. That means port 3.0, port 3.1, 2, 3 like that. We have an 8 lines. 0 to 7 we have an 8 lines. Look at this. This is a port 2. So we have port 2. ISIS it have this 8 lines. Port 2.0 to port 2.7. Similarly, port 0 0 to port 0.7. So each port consists of 8 IO lines. This is the actual SFR, that is a special function registers. For using this timer, IO ports, interrupts, again serial ports, we use this SFRs. That is a special function register. For example, if you take a timer, we have a timer mode control word, timer control word, and then timer, that is a timer 0, lower bit, higher bit, timer 1, lower bit and higher bit. Everything will be available in this SFRs. So not only timer, similarly for interrupt, serial ports and all other things, SFRs will be available here. Look at this. This is the timing and control logic. So program stop enable, ALE, EA and then reset. So these are the control signals that will be connected to this control timing and control unit. It generates all necessary control signals from this unit. So the clock is connected. So look at this. This is the actual crystal and then we have capacitor. We make a sine wave to square wave and we make it a clock pulses. So these clock pulses will be given to the system. So this is the oscillator circuits and given for a clock pulses. Look at this. This is the data pointers. Look at this. This is a DPTR and this is a program counter. This is the incrementer and this is the buffer and this program address generator. So each one. So DPTR is a data pointer to locate that particular address access. We use this program counter. The next instruction to be executed will be pointed by the program counter. So this is the program counter incrementer. Whenever you fetch one instruction, next instruction will be automatically incremented by this logic. Buffer is for a temporary storage. Again, this program address register, so that points that program addresses. Next will be program status word. So we need to have the flag values. So these are the flags available. So the first one, this is an MSB bit. Actually, if we go with an LSB bit, this is the parity flag, overflow flag. This is the register select bit RS0 and RS1, and then user flag F0, auxiliary carry and carry flag. So carry is whenever we have an adding an 8-bit with another 8-bit, the 9th bit output will be called as a carry bit. So this is an actual carry bit, program status word dot 7th bit. And this is an auxiliary carry lower nibble to higher nibble. That is if you take a D3 to D4, there is a carry. That is if you take two numbers, for example, if you 25, add with another 25. So these 5 will be added now. So from this lower digit to higher digit, if there is a carry, then that will be deducted with the auxiliary carries. And this is F0, this is a user flag. It is a general purpose user, so there is a no set or reset automatically. Whenever needs, user can store some information, that is 1-bit information in this user flags. This is the RS0 and RS1. So this is a register selection bit. It will be used to select the 4 banks. So we have a 4 banks, that is a bank 0, bank 1, bank 2 and bank 3. So these banks will be selected with the register bank select bits. This is a overflow flag whenever there is an overflow. So how it means? For example, if you take an 8-bit 2 power 8, this will be a 256. If you use a signed number, minus 128 to plus 127 only can be represented. But if you go with represent with a higher number, what happens? If 127 plus 1, it go for a minus 127. So this overflow will be deducted with the overflow flag. And parity, whenever we have an error correction or deduction, we use this parity bit. Odd parity or even parity depends on this. So depends on available of odd number of ones or even number of ones in accumulator result, this parity bit will be set. Look at this register selection bit, RS0 and RS1. If it is a 00, it selects a register bank 0, the range is 00 to 07. If it is a 01, it selects register bank 1, the range of address is 08 to 0F. 10, it select bank 2, that is a 10 to 17. 11, it select a bank 3, that is a 18 to 1F. Even it consists of 4 bank, at a time we can use only 1 bank. So which bank we are currently using, that will be decided by this RS0 and RS1. Thank you.